So we will have a look at some simple wireless networks now. So we have visited wireless LAN and how it works, and we have also visited what is called gone through a little bit of how to configure VLAN. So and we know how to the basic concepts of how messages and frames of data are sent in a wired network. So that should be helpful in understanding wireless networks. So we'll start again. We'll start with a simple, go for a PC or a laptop or all of any of this. But this is the one I found most easy to configure. So I will use this PC. Let's put it here. Now, if you see here, this PC is on. So let's switch it off. And there is a Ethernet, wired Ethernet LAN port is there, RJ45 port, but it does not have any wireless capability. And unfortunately, there is no other way to insert a wireless module here. So you have to remove this. And then this is a wireless module. You can put it here. This wireless module will provide 2.4 gigahertz wireless interface. Now there are different types of wireless interfaces. Some allow you to use in ad hoc mode, means if you have multiple PCs or computers, you can use wireless connection to one another. Others allow only to connect to what is called an access point. You have probably all seen access point in your university. So before we go to access points, let's configure this. Okay, device must be powered on. Let's power on. Let's go to configuration. You see the Ethernet option is now gone. We have this wireless. As usual, we'll have all this functionalities. This is SSID is the name of the wireless. For example, if it does not matter in this case, this PC cannot provide wireless to any other PC. It can only receive from an access point. In this case, we don't need to do anything. But we can definitely configure we need to definitely configure the address. I will not configure it now because what happens is if you connect to an access point, suddenly it goes into dynamic IP address configuration and I have to again reconfigure static IP. So let's keep it like this. What we can do, however, is we can, copy and then we can paste. You can paste. So 2. So we don't need to again go for another wireless module. Let's change this to PC1, PC2. So we have 3 devices all with wireless capability. We'll now try to connect to an access point. This access point you probably have seen in your universities, colleges, offices, everywhere, wherever you access internet via wireless. So let's go to a network devices as wireless devices. There are many options here. Once again, the easiest I found was this to configure and understand. So this is the access point. Oh, automatically, as you can see, disconnected. As I pulled it down, it got connected. However, if it is not connecting, okay, for example, if it is not connecting, what you can do is you can go to desktop. There's so many apps are there. One of the apps is this configure wireless. If you go to connect and refresh this, you'll find a default. This. Why is it default? Let's see. This is the configuration for the wireless access point. Port 0, let's go into the physical configuration. There is a LAN port, Ethernet port here. We'll see why it is used. It can be used to connect to switches or to other access points. We'll see how to do that, but go for the other. The other is the wireless, of course. This port 1, this is for wireless. Here its name is default. Let's change it to default example, just to see what happens. And then there is this authentication options. So these are the passwords for the wireless. Whenever you're connecting to any Wi-Fi, you need a password. So people configure a password. You can configure a password, for example. Different types of encryption technologies are also there for the passwords. But I have disabled this authentication or password thing. Okay, so encryption is disabled. You can see different encryptions are there for different kinds of, let's say these are protocols or algorithms for encryption, and you need passwords for that. Anyhow, we disable it. You can try all this. If you enable it and give a password, when you connect your PC to this here, see this is showing when you try to connect to this, then you will have to give the password also. But I don't need to do this at this point. Now let's go to the configuration mode, config wireless. Let's give it a this PC0. Once again, we'll follow the same fine. So it now has 10.1.1.1. Config wireless again. To dot 0. Similarly, let's do it here. Wireless static 3 255.0. Finished. 1, 2, 3. Let's now try to connect. Let's connect. Yeah, it's connected. Yeah, unfortunately, what happens is as soon as it connects, it changes. Unfortunately, there's a, you can say there's a problem with the software. It tries to go to dynamic IP configuration, which we'll learn about later on. But this dynamically allocated IP address, it is provided by a server process called DHCP, Dynamic Host Configuration Protocol. If you recall, in one of our previous demonstrations, you connected a PC with a server, and many applications were there in the server. One of them was DHCP. We had seen others like email and FTP and all that. So anyhow, I think we need to first connect and then we need to change. So maybe I'll copy this. So hopefully it won't change next time. So let's connect this and then change it. Connect. Okay, I forgot again. 10.1.1.2. Yes. Let's connect. Connect. Fake wireless static. Three. So all three are connected. All three are connected. So now let's try and ping one PC with the other. So once again, let's go to simulation mode. Drop access point. Okay, desktop command prompt. Let's see if we can. Okay, let me do one thing. Let me move it a little bit left. And then let's see what we can do here. 10.1.1. Let's say 2. So from here to here. Ping, and we'll try to do it only once. Let's see now what happens. Once again, we'll see there will be an ICMP packet generated, but because a MAC address is not known, ARP process has been started. That's fine. But let's see. Now, instead of classic Ethernet 802.3 packet, we have this 802.11 wireless LAN packet being generated. And you can learn about this. It's a very, let's say, complicated kind of frame, and you have multiple addresses, not just 2, sometimes even 4. Yeah, but in this case 3 addresses are being generated. Now I will leave it up to you to figure out which one is what, and experiment, self-study kind of, but we'll see how the network works. So let's see. It goes now. It floods it. So you can obviously understand why it floods it, but you will learn that these access points work more or less like a hub. Because there is no physical wire connecting to it, these access points more or less work like a hub. And that is why in wireless technologies, we need collision protocols to avoid collision. More specifically, we use CSMA, CA, carrier sense multiple access with collision avoidance. And on top of that, we use MECA, multiple access collision avoidance, where we use RTS, return to send, and clear to send CLS messages. And then we have also something called virtual sensing. MECA is physical sensing, real sensing, and something called virtual sensing, which is like keeping a list of all the people connected to the access point. You can think like that. So that is called NAV, network, I think associated vector, or I forgot the exact terminology, but it's called NAV. So anyhow, so it's far more complicated than a simple wired LAN or wired connection. But it is very similar to our telephone network, that is a wireless mobile telephone network. That is why, in fact, you can see you can also put cell towers here. The option is there. You can put cell towers. Similarly, in the devices, where is it? End devices. There is also smartphone. So these wireless networks, whether it is mobile communication or simple internet Wi-Fi that we are using to Wi-Fi that you are using to access internet. They have similar kind of it's a technology working. This is like a mobile tower, you can say. Anyhow, let's go back. So now let's proceed. So ERP received. You should by now understand what is happening. Now this is where, because there is no wired connection, had this been a wired LAN, wired the switch, it would have only sent this ERP packet here. But because it acts like a hub, it floods the packets. And that is everybody receives it. Wherever the PCs which do not need to process the information, they discard it. So this is how it goes. Now an ICMP packet will be generated. Let's put this again here. Okay, I hope it is clear. So let's go again. This is ICMP packet generated and sent. It is packet one, PC1 responds back, and the reply is achieved, and this ends. This process ends. So this is, I hope you understand what's going on. It's simple, but I will leave it up to you to figure out the 802.11 header, because it's a bit complicated to understand. What you can do, however, to help yourself is in the configuration mode. You see this physical wireless. You can change this address. See, you can rename this PC as PCA instead of PC0, make it PCB, PCC. And here you put everything 0 except the last hexadecimal digit, which you put it A. Then the next one you put it B, next one C. So then it will be easier for you to understand what is happening. But I leave that exercise up to you. You know how hub switches, VLANs, LANs all operate now. So you try to find out, understand what is happening here on your own. I will just aid you. I am just aiding you in the first few steps. So now let's make it a little bit more complicated or more realistic rather. So we will have another access point, but first let's disable this. Okay, wireless. Let's disable this. Brilliant. So this cannot connect. This cannot connect to an access point, and put it here, let's say. Okay, let me make it like this. Maybe bring it closer, and let's duplicate this. There is no, okay, we don't need to duplicate it. Network devices, wireless. Which one did we use? This one. Let's bring another access point here. Okay, fine. And let's see what we can do. Port 0 remains at this, port 1. So that was default example. This was default example 1. Let's name it like that. And rest remains same. And PC2, let's see whether it can sense it. Well, sorry. Refresh. Oh, I forgot. I had switched this off. Make it on. Desktop. Refresh. Again, I will refresh. Oh, reset simulation. That's again is an issue here. It's trying to access that, but go to PC wireless connect, refresh. Okay, config wireless. These things happen. This is not a perfect software. Let's put it here. Okay, let's do this. Access point is all on, no issue. Wireless on. Make it real time instead of simulation. Reset simulation, make it real time. This is the issue. We have to understand now why it is happening. Desktop config wireless, switch it off, switch it on. Desktop PC wireless connect. Yes, now it's connect. Let's connect to the near one. Connect. So let's put it here, and these are the two access points. So now let's do one thing. As you saw, there is a Ethernet port here. Now we can connect these two. So for example, in your office or university or whatever, you will see all of this kind of access points hanging on the roof of the ceiling at different places. As you move with a mobile or whatever wireless device, whatever you have, it connects to whatever nearby access point is. And you see the coverage weakens, just like in a cell tower, you move from one cell tower to other, it connects to different cell towers, whichever is nearby. So then it connects to this. So let's say your friend was at a slightly distant place. It was connected to this access point. You are connected to this access point. Okay. So then how do you ping from here to here? The only way is you need to have a wired connectivity. So all these access points are either directly wired, like from one to another, or there is another way, which is the more realistic way. But let's first connect this. Okay. So you have connected this. Now notice something, config. You see the normal configuration, it is given as half duplex in this access point. Similarly, if you see normal configuration is given as half duplex for the Ethernet port it has. This is an indication of the fact that this behaves like a hub, and it needs collision protocols, because in the wireless, whenever it sends any data through the air or a wireless medium, it behaves like a hub. So then in the wired interface also, its normal configuration, it is in the hub. So collision protocols are required in both the cases. So let's see now what happens. So I have this PC. I think it's, yeah, whenever you connect, it loses its, unfortunately, it loses its IP address. See, so yes, this should be 2, should be 1. So let's now come back to simulation. Let's try this. So we'll do what? Go to desktop, command prompt, ping 10.1.1.3, and let's put it 1 time. So let's see. So this one is generated, what is called an ICMP packet as usual. But because it does not have MAC address of this PC, an ARP process is generated. But if you see the ARP process, it does not have any Ethernet frame. Now it has a wireless LAN frame or 802.11 frame. So it goes to the access point it is connected to. Then what happens? Somehow, for some reason, it first sends it through this link as if it knows that this PC is not connected to it. But let's see, let's go on what happens. Let's have a look at this packet outbound. So it's again, I will leave it to you. A5 is the source, ECA5. And what is the A51? This is not A51. This is again, it is not A51. So there is something else here. So you investigate on your own what that is. I will not explain or elaborate on this because otherwise it will take too much time. But it sends here, it receives ARP, but almost the same packet. Let's see. Yes, exactly the same packet. Exactly the same packet. ECA5N, but this is some DD42. What happened here? See? ECA5. So these addresses, you need to keep track of these addresses to understand fully what is happening. And that's why I said that when you do this on your own, rename this PC as PCA, PCB, PCC, and change the MAC addresses to all zeros except the last X. Make it A, B, and C for these three PCs. So when you observe these packets, you will understand what is happening. But now see, it has received. So again, let's go back a little. Here, look at the outbound here, and then again look at this outbound here. I think it's the same, but for some reason it was not able to do this same packet. You can see this packet and this packet. I hope I can, oh, it does not come up. Uh, this I can show both the packets. No, I cannot show. Anyhow, if you will find that both are the same, but it could not transmit both together. Maybe that has to do with something related to half duplex. Maybe you can change it to full duplex and see what happens. These are experiments you do on your own and investigate and report the findings. So this is how we will learn. There is no other way. So now let's go ahead and close this. Obviously, it was meant for this PC, not these two PCs. It responds with ARP. But again, you will find that same packet transmitted. Okay. This is a hub behavior. The packet it sent to this, I think that has been replied back. This is a hub behavior at its finest. In fact, in a hub, if you send a packet through one terminal, it will go out to the rest of the terminals. It will not return back to you. But in case of wireless, it even returns back to you, it seems. So like this, it continues, 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 continues. And finally, it ends. So it ends. So you investigate this behavior. I hope you know what to do. I will recommend you to change these PC names and a MAC address. You cannot do that physically on your actual devices, or you are not allowed to, at least. It will become an illegal thing if you do. But here in this mock environment, you can do that, so you can understand what is going on. So reset the simulation, make it real time. Now what happens, let's go to a more realistic scenario, even more realistic scenario. So we will delete this link. Is it? We'll delete this link, and let's okay, put this somewhere here. Okay, let's put it somewhere here. What will happen in most cases is all this, instead of being connected to one another, because there is only one port here, one port here, they will be connected to a switch. Now, and that switch will be connected to a router. So I had used, I think, this switch here before, but this has only fast Ethernet. Okay. On the other hand, if you take any router, they will have gigabit Ethernet interfaces or ports. So this switch is not a, I've been using this switch for illustration, but when you are connecting to a router, this will not be a good fit, because it can only send at a particular, transmit data at a particular speed. On the other hand, this is having a very high bandwidth interface. So we should take a switch which is having a high bandwidth interface. So let's take a switch. This switch, for example, I think has a high bandwidth interface. Let's see if I click here. Yes, there are 2 gigabit Ethernet ports here. So like this, let's make this come a little bit closer, make closer, come, sorry. And let's put this router somewhere here. So let's now connect this. Okay, automatically choose. That's fine. In this case, there is no issue. However, here, if you try this automatic option, it will probably connect to a fast Ethernet link. Yeah, what happens is fast Ethernet link is connected to gigabit Ethernet. So what you should do is instead choose this fiber optic. You can try it out on your own. And when you do that, you have an option. So click gigabit or Ethernet, and then you click it here, whatever. So both are gigabit Ethernet links. Now, one thing you notice that switch, whenever you connect, it tries to, its default configuration for that port is on. It's always trying to switch on. But in router, default configuration is always switched off. Is because it's a high bandwidth, really sophisticated device, let's say, far so more sophisticated than a normal switch. Router is a layer 3 device. We'll discuss that. And its general configuration is always off. So when you connect here, you go to command line interface also, you can So you put no shut and then you do exit and exit. So now this will come up. Both these links will come up. It will take a little bit of time, but both these links will come up. This has come up. This will also come up. Otherwise, we can command line interface. Yeah, it's up, I think. Yeah, so it will take some time. Yeah, it's green. So now this is what is happening really. There will be many access points in your campus, university, or office, or whatever. You will be connected to one of them at any point of time. Those access points are connected to a switch, or maybe there will be multiple switches there for again connected together. But finally, there will be connection to a router. This router will be your gateway to the internet. See, if you hover around switch, if there is since there is gigabit Ethernet, so there is also something called IP address. But if you take a simple switch, let's say, sorry, made a mistake. If you take let's say this, it does not have a gigabit Ethernet. It also has an IP address. Now I see it. So generally what happens is, we have not talked about this before. Some switches, or maybe all switches now, we were configuring, when we are configuring VLANs, we did not talk about something called, there is an advanced functionality which is called switched vertical virtual interface, SVI. We were using this, let's say, template or poster from packetlife.net to configure this yesterday. If you see that poster itself, that is something written as SVI. There's an enhanced functionality. So you see this, we'll probably not discuss it here, but it is possible to configure IP addresses to also the, at least some interfaces of the switch, and they will behave like a computing device. And there are reasons for doing that. We'll not discuss that in this course, but you can also configure, let's say, IP addresses of a particular for each and every port in the switch. Anyhow, for routers, however, you will necessarily, all of this, any router, you will have to provide an IP address to each and every port it has. Okay, each and every port you will have to provide an IP address. And you can, for example, go here, config here, you can put an IP address. Now, when you provide an IP address for this, let's say, gigabit channel 0 by 0 by 0 link, you see here, in any of these PCs, if you go config wireless, you cannot see it here, unfortunately. If you go to this desktop, let's remove this IP configuration. Unfortunately, the GUI here is not as good, what is called as fluid or as user friendly as you like, but you can get to this prompt. Okay, here there is something called default gateway. This is the gateway to the internet. So this IP address, whatever IP address of this port you will provide, that will be a default gateway. And each of them, this PC will also have a default gateway, same as this port. This also default gateway. You can see here, for example, if you hover around, gateway not set. For example, if I put a gateway here 10.1.1, let's say 254, all of this should be configured with a default gateway 10.1.1.254. So we'll talk about all these things when we discuss what is called network layer and how routing takes place. So when we discuss wired topologies, the same thing will be applicable for wireless. This is the only different part. Okay, this access point and how it connects to the access point. This configuration or these protocols are different. Otherwise, if you replace this with the simple another switch here, and multiple devices, the rest will remain the same. Even if it was a wired network, you will have to give a default gateway of the router, the first router or the nearest router it is connected with, and then you can forward packets and receive packets from the internet. So anyhow, with this configuration, maybe you can put a default gateway. You don't need to provide anything else here. Don't need to make this network any bigger. I can check what happens if you ping from one PC to the other. So I will leave all those exercises to you. I have shown you how to connect the network using the concepts you have learned from simple wired networks, simple LANs, and simple wired LANs, simple wired VLANs, and generally how packets are transmitted. You can use simulation mode and try to visualize and learn about this wireless network. So that's all. So thank you.